In this video, we review everything about a linear equation. The very first important properties of a linear equation is a slope, because all linear equation represents line, and each line has specific slope. How we can find a slope of a line? Equation of a slope, it's difference of y values over of difference of x values. And definitely the order is important. Let's say I have 2 points on the graph of function with coordinate x1 and y1, and p2 it's x2, y2. I can find difference of y values of p1 and p2 and write it as y1 minus y2 or y2 minus y1, but the order of difference of x should be the same. If we have difference of y2 minus y1, then denominator is x2 minus x1, and if we use y1 minus 2, then denominator should be x1 minus x2. In this way, we can find the slope that most of the time we show a slope with m. There are 3 different forms for linear equation. The first form is point slope. When we have a slope, which is m, and 1 point on the graph of function with x1 and y1. If we have a point and slope, then we can write the equation in the form of point slope. Y minus y1 is m times x minus x1. If we have a slope and y-intercept, it means that x is 0. So the point is 0 and y 1. Then we can write a slope intercept form. And here b actually is another point. Let's call it p2. And x is 0. And y value is equals to b. Then we can have a slope intercept form, which is y equals mx plus b. And general form for a linear equation is ax plus by equals c. Here a, b, c are real number. Another thing about linear equation is when we have 2 parallel lines. If we have 2 parallel lines like L1 and L2 here, their slope are equals to each other. So slope of L1 it's equals to the slope of L2. In contrast, when we have perpendicular lines like L1 and L2, multiplication of their slope is equals to -1. So if I have m1, I can calculate m2 or vice versa. For example, m1 is -1 divided by m2. When we want to find x-intercept and y-intercept, it doesn't matter it's about linear equation or any other function. When we are calculating x-intercept, always y is 0, because x-intercept is intersection of graph with x-axis, and definitely y is 0. And to find y-intercept, we set x equals 0. Now let's start working on some problems about linear function. We are looking for the equation of line in the slope-intercept form or general form with the slope -5 and y-intercept 5. Recall that the slope-intercept form of a linear equation was y equals mx plus b when m is slope and b is y-intercept. As you see here, I have a slope as a -5 and y-intercept as +5. So y equals -5x plus 5 is slope-intercept form of line. So this is slope-intercept. If you are looking for the general form, to find the general form, you remember it was ax plus by equals c. We add 5x to both sides. And then we have y plus 5x equals 5. And this is the general form of this line. Now look at this question. Again, I'm looking for the slope-intercept form or general form for a line that passed through the point 0 and 0 and parallel to the line 3x minus y equals to -3. Because the line I'm looking for, it's parallel to 3x minus y equals to -3, I know that the slope of this line is exactly equals to the slope of line that I'm looking for. What is the slope here? This is a general form of a line. It's ax plus by equals c. In this general form, we cannot see a slope. We can rewrite the equation in the form of a slope-intercept, and then in that form, coefficient of x, it's equals to the slope. So the first step is to rewrite the equation. 3x minus y equals to -3. I want to rewrite it in a slope-intercept format. What was that format? It's y equals mx plus b. It means that y, it's in one side, isolated, and the coefficient of y, as you see, is +1. So the first step here to isolate y is subtracting 3x from both sides. And then dividing by the coefficient of y, which is -1. If I divide that by -1, then y is +3x plus 3. Now, coefficient of x is a slope. I have a point on the graph of function. x1 is 0 and y1 also is 0. With having a point and a slope, right now I can find the equation of line. Y is equals to m times x plus b, which is 0. Why I'm using a slope-intercept form? When we have a point and a slope, I should put it in the point-slope format. Y minus y1 equals m times x minus x1. Here, because the point was 0, 0, and x equals 0, the point actually is y-intercept. It means that y-intercept also equals 0. So it doesn't matter that I put it in this format, a slope-intercept or point-slope. Let's put it in the point-slope. y1 is 0, m is 3, and x1 also is 0. If you simplify, y is 3x. In the next question, again, I'm looking for the equation of line in the form of slope-intercept. I have a point, which is x1 and y1, and perpendicular to the line y equals 1/3 of x minus 3. When we look at the equation of line y equals 1/3 of x minus 3, because it's in the form of a slope-intercept, you see the slope as coefficient of x. So here, slope, it's equals to 1/3. Let's call it m1. I'm looking for a line perpendicular to this line. So the slope of line that I'm looking for, it's -1 over m1, or -1 times reciprocal of m1. Reciprocal of m1 is 3 over 1 or 3. So m2, or the slope, is -3. Now I have a slope and a point. We can substitute in the equation of point slope and write the equation of line. Here, x-intercept, not x-intercept. Here we have x1 as -3 and y1 as 9. So it's not similar to the previous question, because in the previous question, x1 was 0, and then I mentioned that y-intercept is 0 because the point was 0 and 0. Here, we definitely need to plug in the equation of point slope, and if we want to write it in the form of a slope-intercept, then we need to simplify. So y minus y1 equals to m times x minus x1. Y minus 9 equals to -3 times x plus 3. And for the next step, we multiply -3 in the parentheses, and then we have -3x minus 9. To get rid of -9 here, we add 9 to the both sides, and y equals -3x. It's the equation of line. As you see, this is the equation in the form of point slope, and also you can call it a slope-intercept because y-intercept again is 0. Okay, that's all about the linear equation.